In the previous class, we learnt about monohybrid cross. That was a classical experiment of Mendel which led to the formation of the first law of Mendel, that is the principle of dominance. In the same experiment, we saw the genotypic ratio of 1:2:1. This was the genotypic ratio. In F2 generation. In F2 generation, we saw that the recessive character which disappeared, which did not appear in F1 generation, appeared in pure form in F2 generation. This led to the formulation of another law of Mendel, which was known as law of segregation or the principle of segregation. In this principle, it states that in a heterozygous condition, one of the allele pair which disappeared in F1 generation appeared in pure form in F2 generation. So we saw the ratio, the recessive character which did not appear in F1 generation appeared in pure form in the F2 generation. So this led to the formation of principle of segregation. Today we are going to learn about the dihybrid cross, which led to the formulation of the third law, that is law of independent assortment. In a dihybrid cross, Mendel took two contrasting characters in homozygous condition. So let us see. We can take the color of the seed. Let us take yellow. Yellow will be dominant color. And green recessive. Then shape of the seed. We can take round, dominant, and wrinkled as recessive. Mendel crossed homozygous yellow and round with homozygous green and wrinkled. Shape of the seed that Mendel took, the dominant was round and recessive was wrinkled. So the gametes that Mendel got is round and yellow as dominant and wrinkled and green as recessive. On crossing over in F1 generation, Mendel got all the hybrids were round and yellow. So all the hybrids were, that is the progenies, all the progenies were hybrid. And were round and yellow. So in F1 generation, what Mendel got was all the progenies were yellow and round, that is they were hybrid dominant. When Mendel set the F1 generation, that is he took round and yellow male and female. What he got is different varieties of hybrid. He got 9 round and yellow, 3 yellow and wrinkled, round and green he got 3, and green and wrinkled he got 1. So the phenotypic ratio that Mendel got was 9:3:3:1. So what you have to do is draw a Punnett square and then take the chemies and do the crossing over. So this way I have done it. So you have to do like this. So we have to do the crossing over. Show the crossing over in Punnett square. F2 crossing over has to be shown in Punnett square. Now let us know what is Punnett square. Punnett square is a graphical representation to calculate the probabilities of the possible genotype that shows the progenies in a crossing over. It was developed by Reginald C. Punnett. So all the crossing over in F2 generation has to be shown in a Punnett square. So 16 squares we have to draw. The genotypic ratio that Mendel got was like this: 1:2:2:4:1:2:2:1:2:1. That means the ratio that Mendel got was 9:3:3:1. So this was the dihybrid cross which Mendel performed with 2 genes. He took 2 contrasting characters. In his trihybrid experiment cross, he got the same results. That is, one of the characters segregated. When 3 pairs of contrasting characters were taken, one of the characters segregated and became independent of the other. There was no blending of characters. So this was known as law of independent assortment. This led to the formulation of Mendel's third law, that is law of independent assortment. So the cross in dihybrid and trihybrid, that is experiment that Mendel did in dihybrid and trihybrid cross, it led to the formulation of a third law, that is law of independent assortment, which states that when 2 or more pair of contrasting characters are taken, one pair segregates and becomes independent of the other. Mendel in his time was not aware of linkage, crossing over or gene interaction. The third law of Mendel can be modified or is modified as the gene of one chromosome does not interfere or mingle with the gene of another chromosome of the same homologous pair. Mendel's third law, that is the law of independent assortment, is modified as the gene of one character does not influence the gene of another character if they are present on different homologous chromosomes.